Before touching the code, let's clarify what this project does. This project trains a sentiment classification model on the Stanford IMDb movie review dataset. It uses TensorFlow 2, a small BERT model from TensorFlow Hub, Atom W optimization with warmup, TensorFlow save model for export, and optional deployment to Google Cloud Vertex AI. What's important is not just what we're training, but how the code is structured. This project is intentionally broken into configuration, data loading, model construction, training, exporting, and a command line interface. That separation is what makes this production ready. Now we're going to walk through the README file for this project. The README is the entry point for anyone encountering this repository for the first time. It answers 3 critical questions right away. What does this project do? How do I run it? And how is it structured? Everything else in the codebase builds on what is described here. At the very top, the README introduces the project as a BERT text classification system. It immediately tells us that this project trains a sentiment classifier on the Stanford IMDb movie review dataset. That choice of dataset is important because IMDb is a well-known, real-world benchmark for sentiment analysis, not a toy example. The README also clarifies that the model is built using a TensorFlow Hub small BERT encoder, paired with a matching pre-processing model. This detail matters because it signals that the project is using pre-trained language models, not training embeddings from scratch. That means faster convergence, better language understanding, and more realistic production patterns. Finally, the opening paragraph tells us what the full lifecycle looks like. Training the model, exporting it as a save model, running local inference, and optionally deploying it to Vertex AI for online prediction. Right away, the README establishes that this is not just a training script, it's an end-to-end ML workflow. The next section is labeled Quick Start, and this is where most users will begin. The Quick Start is focused on local training and local inference, which is intentional. Good ML projects always work locally first. Cloud deployment is optional and comes later. The README then lists prerequisites. It specifies a modern Python version, pip and virtual environments, and sufficient disk space to hold the IMDb dataset. This may seem basic, but it's important documentation hygiene. It sets expectations early and prevents users from running into confusing errors later due to incompatible Python versions or missing disk space. Next, we move into the setup instructions. The README walks the user through creating a virtual environment and activating it. This step isolates dependencies and prevents conflicts with System Python or other projects. Then it instructs the user to upgrade pip and install dependencies from the requirements file. These dependencies include TensorFlow, TensorFlow Hub, TensorFlow Text, and supporting libraries for optimization and cloud deployment. The README also includes installing the project itself in editable mode. This is a subtle but important step. Installing in editable mode ensures that the Python interpreter can locate the project package correctly when using the command line interface, and that changes to the source code take effect immediately. At this point, the environment is fully prepared. After setup, the README moves on to training and export. This section shows a single command that performs multiple actions. When this command is run, the IMDb dataset is downloaded into a local data directory. The model is trained, and a TensorFlow save model is exported. The README explicitly states where the dataset will live and where the exported model will be written. It also highlights that the export path includes a timestamp. This design allows multiple training runs to coexist without overriding each other, which is essential for experimentation and comparison. The fact that training and export are combined into a single command reinforces the idea that export is not an afterthought. It is part of the standard training lifecycle. Next, the README explains how to run local prediction. This step uses the exported save model, not the in-memory training model. That distinction is critical. By forcing inference to use the exported artifact, the project validates that the model is truly portable and ready for production use. The README shows how to pass multiple pieces of text to the CLI and receive predictions. This makes it easy for users to sanity check the model's behavior immediately after training. After covering local workflows, the README introduces optional cloud deployment using Vertex AI. This section is clearly marked as optional, which is good design. Not every user wants or needs cloud deployment. and the README respects that. Before showing any commands, the README lists the prerequisites for using Vertex AI. These include having a Google Cloud project with billing enabled, authenticating with cloud, and having appropriate permissions. By listing these requirements upfront, the README prevents half-completed deployments and confusing permission errors. The Upload and Deploy section shows a single command that handles the entire cloud deployment workflow. This command ensures a cloud storage bucket exists, uploads the save model artifacts, registers the model with Vertex AI, and deploys it to an endpoint. The README even explains these steps in plain language, so users understand what is happening behind the scenes. This transparency is important for trust and learning. Next, the README shows how to run online prediction. This command sends text input to a deployed Vertex AI endpoint and receives predictions in real time. This demonstrates that the same model trained locally can be served at scale without changes to the core logic. The README also includes a cleanup section. Cleanup commands undeploy the model and delete the endpoint. This is an important best practice. Cloud resources continue to incur cost if left running, so having an explicit cleanup step encourages responsible usage. After the cloud section, the README provides a notes section. This section documents the default BERT models used, including both the encoder and preprocessing modules. It also explains that training uses AtomW with linear warmup, which is a best practice for transformer fine-tuning. The README further notes that the exported save model is compatible with TensorFlow 2 pre-built serving containers on Vertex AI. Finally, it includes a practical note about macOS and TensorFlow installation, acknowledging real-world development challenges and offering alternatives. The README then presents the repository layout. This section is essentially a map of the codebase. It lists each major module and explains its responsibility in one line. This helps new contributors quickly understand where to look when modifying or extending the project. It also reinforces the architectural separation between configuration, data, modeling, training, exporting, deployment, and the CLI. At the very end, the README includes a one-liner help command. This shows users how to discover available CLI commands and arguments without reading source code. This is another signal that the project is designed to be used as a real application, not just studied as an example. To summarize, this README does more than explain how to run the code. It communicates the philosophy of the project. It emphasizes reproducibility, clarity, separation of concerns, and production readiness. It guides users from local experimentation to optional cloud deployment, without forcing unnecessary complexity. As a result, the README acts as both documentation and onboarding guide for the entire system.